Question 5. F of x equals to 2x squared plus 4x plus 9. X for all real number. A, write f of x in the form of that's completing the square. And B, sketch the curve with the equation y equals f of x, showing any points of intersection with the coordinate axis and the coordinates of any turning point. C1. Describe fully the transformation that maps the curve with equation y equals f of x onto the curve with equation y equals g of x, where g of x is 2 into bracket x minus 2 close bracket squared plus 4x minus 3. Part 2, C part 2, find the range of the function hx equals to 21 over 2x squared plus 4x plus 9. X for all real values of x. So for the function of f of x, I need to apply completing the square. What I've done is I've taken 2 as a common factor from the first 2 terms, because completing the square only affects the first 2 terms. So I've taken 2 out as a common factor. So what I did was I then turned the x squared into x. I bring the plus sign down. I divide that by 2. That's x. That's b over 2. So this is b over 2. And I square it. And I take away the square of b over 2, which is b over 2 is, in this case, is 1. And I take away the square of b over 2, which is 1 squared, minus 1 squared. So this is what I've done. This is what we have, ax squared plus bx plus c. By completing the square, you take out a as a common factor from the first 2 terms. And this is what happened when you take a out. And then you turn the x squared into x. You bring the sign down, and you divide this value here by 2. So that's b over 2a. Now you square that and take away the square of this one here. And let's take away the square. So that's what I've done here. Remember, a is 2, b is 4, and c is 9. And then I close the bracket here, plus c at the end. So the completing the square only affects the first 2 terms. So now I've expanded the bracket here. I've taken the square bracket out and I've expanded this. So I get 2 into bracket x plus 1 squared minus 2, because 2 times 1 is minus 2, and then plus 9. So finally, I then get 2 into bracket x plus 1 squared plus 7. So for part A, f of x using completing the square is 2 into bracket x plus 1 close bracket squared plus 7. Now for part B. So at the turning point, we set the bracket to 0, x plus 1 equal to 0, and I give x equals minus 1. So at the turning point, x is minus 1, and it crosses the y-axis at 9, and the value of y at the turning point is 7. So this value here gives the turning point of y, and this one in bracket gives the turning point of x when you set it to 0. So at the turning point, we have x to be minus 1 and y to be 7. In order to plot this graph, I have decided to solve this equation by setting that to 0. And that's what I've done here. I've set it to 0, and I take the plus 7 to the other side is minus 7, and divide both sides by 2. And so therefore I got minus 7 over 2. And then I square root both sides, which is x plus 1 equals plus or minus root minus 7 over 2. Now this is a complex situation. It's not a real root, and therefore it does not cross the x-axis. Because the graph does not cross the x-axis, because it's got a complex root, I can then need to draw the graph. The turning point will be at y equals to 7, y will be equal to 7, and x will be equal to minus 1. So the graph will look more like that. So this is what the graph looks like at the turning point, where x is minus 1, which is what you have here, and y is 7. And you can see it's a complex root because it does not cross the x-axis. It's got intercept on the y-axis at 9, but the turning point is at minus 1 and 7. 5c. G of x is 2 into bracket x minus 2 close bracket squared plus 4x minus 3. F of x is 2x squared plus 4x plus 9. you can see here there's been a problem here. The x here is now being translated by 2 to the right. That's why you've seen the x minus 2 here. If I set that to 0, x will be equal to 2. So what I've done is, because I now knew that the x here has been translated by 2 to the right, so what I did was replace f of x here with f of x minus 2. And then I need to expand this. So the clue came from here. So the f of x minus 2 is giving us 2 into bracket x minus 2 close bracket squared plus 4x plus 9. But what we had was plus 4x minus 3. To get minus 3, I need to take away 4 from both sides. If I take away 4 from here, if I do minus 4, I have to do minus 4 on the left-hand side too. So that means that now the function has been shifted to the right and then down. That's what this meant. The function has been shifted, because if you set that to 0, you're going to get x equals 2. So it's been shifted to the right at x equals 2 and down by minus 4. And this is the function. So now this is g of x. The f of x has been translated by 2 to the right and minus 4 down. So the translation by the vector 2 minus 4. So 5c part 2, h of x is equal to 21 over 2 into bracket x plus 1 to power 2 plus 7. So that's f of x. This is a set for all x having real value. So we got a function of h of x, which is 21 over the function of f of x. And we're finding the range of value of this function. And what we have to do is set the denominator, the bracket here, to 0. Therefore, x equals minus 1. So we want to find h of minus 1. So h of minus 1 equals 21 over 7, because when you put x equals to minus 1, you get 0. So you're going to get 21 over 7, and 20 over 7 equals 3. So as x increases, h of x gets closer to 0. And so 0 is less than h of x, which is less or equal to 3.